Today, we'll kick off by setting up everything you need to build your first AI assistant. First, let's clarify what we'll create. A simple AI assistant with a chat interface using Chainlit, powered by Ollama for AI responses. This assistant will handle chat interactions and focus on AI and backend engineering topics. You'll see how Chainlit structures the UI while Ollama handles the intelligence. Before coding, we need two prerequisites. First, ensure Python is installed on your machine. This is the backbone of our project. Second, install Ollama locally and load a model like Mistral. This runs the AI engine behind your assistant's responses. Our assistant will specialize in AI and backend topics, giving you hands-on experience with real-world engineering challenges. Let's verify your setup before moving to code structure. Now, first, we import Chainlit as CL. Chainlit is the framework that provides the chat interface and handles the conversation flow. We alias it as CL for cleaner code. Next, we import requests. This library is essential for making HTTP API calls to our Ollama server. It's one of the most popular Python libraries for working with APIs. Then we import JSON. We'll use this to parse the JSON responses we receive from the Ollama API. It converts the response data into Python objects we can work with. Now for the configuration variables. Ollama URL specifies where our Ollama server is running, and model name tells us which AI model to use for generating responses. Finally, system prompt defines how our AI assistant should behave. This is crucial for setting the tone and capabilities of our chatbot. Now that we've covered the imports and configuration, let's dive into how these components come together during chat session initialization. This line outlines the critical setup process when a user starts a new chat. The @CL on the chat start marks the initialization function. When a chat session begins, Chainlit automatically triggers this decorated function to prepare the environment. First, the decorator handles chat initialization. Second, we use cl.userSession.set to persist conversation history across interactions. Third, message history is initialized with a system prompt to guide the AI's behavior. Fourth, the function returns a welcome message to greet the user. Finally, this entire setup establishes the foundation for multi-turn conversations, ensuring context is maintained throughout the session. Now let's dive into the message handling function, which is the core of our chat application. This is where we process incoming user messages and prepare them for AI response. First, we use the clen.onMessage decorator. This tells Chainlit that this function should be triggered whenever a user sends a message. It's the entry point for all user interactions in our chat. Notice we define this as an async function. This is crucial because we're dealing with non-blocking I/O operations. The async keyword allows our function to wait for responses without freezing the entire application. Next, we retrieve the existing message dark history from the session. As we just covered in the previous function about session initialization, this maintains context across multiple messages in the conversation. We then append the user's message to the conversation history. This ensures that when we send a full conversation to Ollama, it has the complete context of what's been discussed so far. Finally, we create a placeholder message for streaming output. This prepares the UI to receive the AI's response in real time as it generates, which we'll explore in the next section on Ollama API integration. Now let's dive into the Ollama API integration with streaming. This is where the magic happens, connecting our chat application to the AI model in real time. The streaming response processing flow is critical for creating that smooth conversational experience. Instead of waiting for the entire response, we process it as it arrives. First, we use requests post to send an HTTP post request to the Ollama API. This is the standard way to communicate with most REST APIs. The key parameter here is stream equals true. This enables streaming response mode, which is what allows us to receive tokens as they're generated rather than waiting for the complete response. Once we get the response, we use response.iter lines to process the response line by line. Each line contains a chunk of the AI's output. We then parse each line using JSON.loads to extract the actual message content from the JSON format that Ollama sends back. Finally, msg.update updates the message in real time as tokens arrive, creating that typing effect users expect from modern chat applications. This streaming approach is what makes the conversation feel natural and responsive. Building on what we just covered about the Ollama API integration, let's now dive into how we maintain conversation context. This is crucial for making our chat application feel natural and responsive across multiple messages. First, our message history array stores every conversation turn. Each entry includes the role, whether it's system, user, or assistant, and the actual content. This structure allows the model to understand the flow of the conversation. Next, this history is passed to the Ollama API with each request. This ensures the model has full context, enabling it to generate responses. After receiving a response, we save the assistant's reply back into the history. This way, the conversation state persists across multiple interactions, maintaining continuity for the user. In summary, managing conversation history effectively is key to creating a seamless chat experience. By tracking roles, content, and persisting state, we ensure each message builds logically on the last. Enough code. Now let's actually run this and see our AI chatbot in action. First, make sure you are inside your project folder, where your app.py file is present. Chainlit run app.py. Hit enter. You'll see Chainlit starting a local server, something like running on localhost. Awesome. You now have your own ChatGPT-like interface. Let's test it. Let's ask, explain what is Kubernetes in simple terms. Notice this. The response is not coming all at once. It's streaming token by token, just like ChatGPT. This is happening because we enabled streaming in Ollama. And we are updating the UI in real time. Another question, can you give me a real-world example of that? Now watch this carefully. The AI remembers the previous question, so it continues the conversation naturally. This is because of message history. Write a simple Spring Boot REST API example. You can see it's giving structured code. Because we set the system prompt, it behaves like an AI plus backend expert. As we wrap up today's session, let's review the core concepts we've built together. Key takeaways include how Chainlit streamlines chat interface creation, the importance of streaming for real-time user feedback, and session management for maintaining conversation context. For your next steps, consider enhancing the application with file uploads, multi-model support, or user authentication to expand its capabilities. These extensions will help you build a more robust, secure, and versatile chat system ready for production use.